Alright, so in this problem I have 9 to the power of x plus 12 to the power of x is equal to 16 to the power of x. So I'm going to first start by dividing every term by 9 to the power of x. So 9 to the power of 9 to the power of x, those two cancel out. So I have 1 plus 12 over 9 to the power of x, which simplifies to 4 over 3 to the power of x. And 16 over 9, which simplifies to 4 squared over 3 squared to the power of x. Now, this is the same thing as 1 plus 4 over 3 to the power of x is equal to 4 over 3 squared to the power of x. And if I let 4 over 3 to the power of x equal to the variable y, I get 1 plus y is equal to y squared. This is the same thing as y squared minus y minus 1 is equal to 0. Now, by using the quadratic formula, if you use it, I'm not going to do it now, but you should get that y is equal to 1 plus or minus the square root of 5 over 2. Now, remember how we let y equal 4 over 3 to the power of x. So we have 4 over 3 to the power of x is equal to 1 plus the square root of 5, 1 minus the square root of 5 over 2, and 1 minus the square root of 5, that's going to be a negative number, and you can't take the power of a positive number and make it negative, meaning the only solution for y that works is 1 plus the square root of 5 over 2. So now to solve this, I'm going to take the log on both sides. So I have log 4 over 3 to the power of x is equal to log 1 plus square root of 5 over 2, and now I can actually move this x to the front. So now I have x times log 4 over 3 is equal to log 1 plus the square root of 5 over 2. Now if I divide both sides by log 4 over 3, these two cancel out, so I'm left with x is equal to log of 1 plus the square root of 5 over 2 over log 4 over 3. Alright, so in this problem I have 36 to the power of x minus 6 to the power of x is equal to 1,260. So I'm going to first start by subtracting 1,260 on both sides. So then these two cancel out, and I have 36 to the power of x minus 6 to the power of x minus 1,260 is equal to 0. Now 36 is the same thing as 6 squared. So I have 6 squared to the power of x, and I can actually switch the places of these two. So this is the same thing as 6 to the power of x squared minus 6 to the power of x minus 1,260 is equal to 0. Now I'm going to let 6 to the power of x equal to the variable y. So now I have y squared minus y minus 1,260 is equal to 0. Now I'm going to replace negative y with negative 36y plus 35y. And now y squared minus 36y is the same thing as y times y minus 36 plus 35 times y minus 6 is equal to 0. Sorry, 36 times y minus 36. And now if I factor out y minus 36, I get y minus 36 times y plus 35 is equal to 0. So this means that y minus 36 is equal to 0, and y plus 35 is equal to 0, meaning y equals 36, and y is also equal to negative 35. Now remember how we let 6 to the power of x equal y. So to start, we have 6 to the power of x is equal to 36, and we also have 6 to the power of x is equal to negative 35. So for 6 to the power of x equals 36, x is obviously equal to 2 because 6 squared is equal to 36. So this is one solution of x. Now 6 to the power of x equals negative 35. This will actually not work because you can't take the power of a positive number and make it negative. So my only solution is x equals 2. Now let's go ahead and check to see if this is right. So I have 36 to the power of x minus 6 to the power of x is equal to 1,260. So I have 36 squared minus 6 squared is equal to 1,260. And this is the same thing as 36 squared is equal to 1,296 minus 36, which is equal to 1,260, meaning 1,260 is equal to 1,260, and because this is right, our solution is right. Alright, so in this problem, I have 2 to the power of x minus 2 to the power of y is equal to 120. So at first glance, we can already tell that 2 to the power of x is greater than 2 to the power of y, because 2 to the power of x minus 2 to the power of y is a positive number, meaning x is greater than y, because both of these have the same bases. So because we know that x is greater than y, we can say that x is equal to y plus some variable k. So now I'm going to replace x with y plus k. So now I have 2 to the power of y plus k minus 2 to the power of y is equal to 120. Now if I have something in the form a to the power of m plus n, this is equal to a to the power of m times a to the power of n. So 2 to the power of y plus k, that's going to equal 2 to the power of y times 2 to the power of k minus 2 to the power of y is equal to 120. Now if I factor out 2 to the power of y, I get 2 to the power of y times 2 to the power of k minus 1 is equal to 120. Now 120, this is the same thing as 8 times 15. And notice how we have an even number, 2 to the power of any number is even, times an odd number, because an even number minus 1 is going to be odd, is equal to an even number times an odd number, meaning these two even numbers are equal to each other and these two odd numbers are equal to each other. So we have 2 to the power of y is equal to 8, and 2 to the power of k minus 1 is equal to 15. So let's first start off by solving 2 to the power of y equals 8. Well, we obviously know that y is equal to 3, because 2 to the power of 3 is equal to 8. Now for 2 to the power of, this is actually 2 to the power of k minus 1. Negative 1 is not part of the exponent. So I'm going to start off by adding 1 on both sides. So I get 2 to the power of k is equal to 16, meaning k is equal to 4. Now remember how we set x equals y plus k, and k is 4, y is 3, meaning x is 7. So now to check, my original equation was 2 to the power of x minus 2 to the power of y equals 120. So we know that x is 7 and y is 3. 2 to the power of 7 is 128, minus 2 to the power of 3 is 8. So I get 120 is equal to 120.